In the final part of this video series, I'm going to show a brief comparison between linear regression procedures in 3 software packages. So far, I've been focusing exclusively on the R statistical computing environment. I'm also going to show you today how to do some linear regression in Jamovi and in SPSS, 2 other commonly used statistical packages. The 6 steps that I'm going to follow in each of these packages are data import and preparation, carrying out one simple linear regression model with price as the response variable and battery as the predictor, a model with a binary predictor, that will be material, a model with a multi-categorical predictor, that will be color, a model with 2 predictors, battery and color, and a F-test for model comparison, comparing the battery model to the battery plus color model. I'm going to fit all the same models in these 3 software packages so that you will be able to see that the numbers that we get in the output are precisely identical. First, I'm going to show these steps in R, even though you should at this point be pretty familiar with how to carry out these steps in R. The first step that I'm going to show, though, is reading in the data, just for consistency with the other software packages. So I've created a robots.csv file, a CSV file containing the robots data frame, so that I can use R code to read that CSV file in, create a new data frame based on it, and then carry out the analysis. So that's what this first step does up here. It reads the existing CSV file. By default, the read.csv function stores all strings as character vectors rather than as factors. You can use these strings as factors equals true argument to read.csv to avoid this problem, and then you will not need to convert anything to a factor after you run this function. But in this case, I'm showing how to manually convert these 3 variables to a factor, because I think it's a better habit to let read.csv keep everything as a string initially, because most psychological data sets have a bunch of string variables in them that we definitely don't want to be factors, like comments that participants gave or open-ended responses to an ethnicity question or something like that. So now I'm on to the simple linear regression step. Here's how to do simple linear regression with one continuous predictor in R. I'm using the LM function, price is the response, battery is the predictor, comes from the robots data frame, and I'm calling summary and confint on the resulting model object, and I get a nice regression table, and I get some confidence intervals for the slope and intercept. I'm going to show you how to get this same regression table and confidence intervals in other software packages. Here's the same thing, but with the binary predictor. Material is the predictor now. It's a factor, so it gets coded with this contrast plastic, and I get a table with regression slopes and hypothesis tests of that slope, and a confidence interval for the slope and for the intercept. Here it is with a multi-categorical predictor, color, and as we've repeatedly seen in the previous demonstrations, color gets automatically coded using 3 indicator variables representing the contrast stored with the factor color, which by default had the first color in alphabetical order, black, as the reference category, and these slopes represent comparisons between blue and black, green and black, and red and black, and we have confidence intervals for each of those comparisons. Here's the version with 2 predictors, and we get a regression table where battery has its own slope, and then there's still 3 slopes representing the relationship between color and price, adjusting for battery, and we have confidence intervals for all of those estimated parameters. And here is the model comparison step. The question we're trying to answer here is whether the model that has battery and color as predictors fits significantly better than the model with battery alone. So I'm calling the ANOVA function with the battery model as the first argument, the simpler model, and the battery color model, the more complex model, as the second argument. And I get this table showing that there's an F with 3 and 495 degrees of freedom that has a value of 10.23 and a low p-value indicating that introducing color into the model significantly increases the variance explained. So I'm going to show how to carry out those same steps in Jamovi. So first I'm going to walk through the data preparation. Here's what you will get if you open Jamovi without doing anything. It has sort of a blank space for data over here and a space for output over here. We're going to click on the 3 horizontal bars to open the menu. We're going to click on Open and choose the CSV file that we want to analyze. And it will result in a spreadsheet-like display of that CSV file in the left panel. In order to carry out the simple linear regression model, we're going to click on the Regression button and then the Linear Regression sub-option under that menu. And that automatically brings us to a screen that looks like this, where we have blank results ready to fill in on the right, and an interface to specify the linear regression model on the left. And as we specify that model, the preview of the results will automatically update. So we want the price variable to be our dependent variable, so we will click on it in the list of variables, and then click on the arrow to put it in the dependent variable box, and then we'll click on battery in the list of variables and click on the arrow to put it into the box labeled covariates. Covariates is a synonym for numeric predictor variables in a linear regression model, and so that's where we want it to be. The box below it, labeled factors, is for categorical variables. And having done that, we already have a regression summary table that has an intercept and a slope and a t-statistic and a p-value. So that's already part of the way towards what we're trying to get with simple linear regression. But we also wanted confidence intervals. So to find those, we need to go into this set of options down near the bottom on the left called Model Coefficients and check the box for a confidence interval. Having done that, the confidence interval is added to the regression output table over here. And we've completed the steps that we did for simple linear regression in R. Moving on to the binary predictor, I'm going to click on the regression menu and choose linear regression again to start a new one. You'll see that this creates a new blank output space below the previous one, and then it brings us to the same interface on the left to add variables into boxes. And so additional output will get added to this list as you do more analysis. So the previous output is still there. I'm going to choose price and put it in the dependent variable box by clicking on it and then clicking on the arrow. And then choose material and put it in the factors box by clicking on the corresponding arrow. That's because material is a binary variable and it's stored as text here. And so it needs to be in the factor box to tell R to tell Jamovi, which is based on R, to treat it as a categorical variable. We get a regular regression output table with slope, estimate, standard error, and p-value like normal. The way the factor is represented is slightly different from in R. We get this plastic minus metal. That just means that metal is the reference category. And here we're seeing how much lower plastic is than metal. And so the difference between plastic and metal is negative 9.98. That's the slope for the indicator variable plastic in this model. And to add a confidence interval for that slope, we go into the Model Coefficients menu and choose Confidence Interval. I'm going to follow the same steps again in order to add a multi-categorical predictor. So I put price in the dependent variable box and color in the factors box, and I check the box for confidence interval, and I get the regression table that I want for the color predictor. Black is the reference category, so it's shown next to each of the indicator variables here. And 2.64 represents the slope for the blue indicator variable, comparing blue to black, and so on. These numbers are all the same as what we got in base R. I'm going to repeat the steps to have two predictors in the model. And so I put price in the dependent variable box, battery in the covariates box. I could add as many variables as I want to the covariates box, as long as they're all numeric. And I put color in the factors box. I could add as many variables there as I want, as long as they're all categorical. Here I just have one of each. And I checked the box for a confidence interval, and now I get a regression table for a model that has all four of these predictor terms, one representing the slope for battery and three representing the relationship between color and price, adjusting for battery. And when I want to do the model comparison in Jamovi, I need to do something slightly more complex. I don't set up both of my regression models ahead of time and then compare them. Instead, I need to go to the Model Builder menu within one of my regression models. Actually, it has to be within the more complex regression model. So here I'm just continuing to use the linear regression output in Jamovi that I got from fitting the model that has price as the response variable or dependent variable, and battery and color as two predictors. And I'm continuing to modify its options. So I'm going to click on this Model Builder button, and it opens an interface like this, showing that currently I have one block and it contains these two predictor variables. These blocks are just kind of like representations of models that I want to run in sequence that are similar to each other except for the inclusion of additional variables. So the first thing that I'm going to do in order to set up the model comparison I want is add a new block. And having done that, I now have block 1 and block 2, and block 2 is sort of empty, ready for me to set it up. Then I'm going to select the color variable in block 1 and press the leftward pointing arrow to remove it from that block. And then I'm going to click on block 2 in order to select it, and then select the color variable from the predictors on the left and press the rightward pointing arrow to move it into block 2. So now this representation of the series of models has battery in block 1 and color in block 2. And the result of including battery in block 1 and color in block 2 is that it fits one regression model that has only battery as a predictor. That's what block 1 is. And then block 2 is another regression model that will have all the same predictors as block 1 and then some. So this is a shorthand way of telling R, I want two regression models. The first one is just battery, and the second one is battery and color, and I want to compare those two regression models. And so in the output, we have the F-test with 3 and 495 degrees of freedom with a value of 10.2 and a low p-value indicating that adding color to this model significantly increases the variance explained. And we also have the regression table for the more complex model displayed by default. And I could click on this drop-down menu and change it to model 1 in order to view the results of the model that has only battery as the predictor. Moving on to SPSS, in order to read the CSV file that I created into SPSS, we actually have to follow a somewhat lengthy series of steps, unfortunately. Anything in SPSS could also be done using SPSS syntax, but I'm not covering that here. Happy to talk about it if you want to, just reach out to me. So in order to read in the CSV file, I'm going to go to File, Import Data, and choose the CSV Data option. And then I'm going to find the file corresponding to the data that I want to analyze, robots.csv. And then I get this sort of Read CSV dialog box. And you might be tempted just to click OK here, but if you do, all the numeric variables will be stored as strings. So I need to click on the Advanced Options button in this dialog box, and then click through some of the Text Import Wizard dialog boxes. So I can click Next on the first one, there's nothing I need to change here. I can click Next on the second one, there's nothing I need to change here. Click Next on the third one, there's nothing I need to change here. Click Next on the fourth one, comma is the separator, the double quote is the text qualifier, there's nothing I need to change here. And finally, in the fifth step of the Text Import Wizard, I need to click on, in the little data preview, I need to click on mass because it's my first numeric variable. And I'm going to select all of my numeric variables and change their data format from automatic to numeric. So I'll click on mass, and then I will hold down Shift and click on rating.pool in this case in order to select the set of 6 numeric variables that are included in this data set. And then I'm changing the data format using the drop-down menu from automatic to numeric to force SPSS to represent these 6 variables as numbers instead of strings. And then I can click Next, and then I can click Finish. And now I've imported the CSV file. I could have just skipped the Text Import Wizard advanced options and had these variables as strings and then converted them to numeric after importing, but I think this way is easier. And then I'm going to click on the Variable View tab on the bottom because I think it's easiest to work in SPSS when you're looking at the Variable View interface. This just gives you some summary information about each of the variables. And I'm glad to see that mass, battery, price, and the 3 ratings are numeric. I'm still not done with the data preparation though, because if I want to use transport, material, and color as predictors in a regression model, they need to be 0s and 1s. That is, I have to manually compute the indicator variables for all of what would be factors in R in order to fit a regression model in SPSS. So I'm going to go to transform and recode into different variables. I'm going to choose the transport variable in the list of variables on the left and then press the rightward pointing arrow to move it into the input variable box in the center of this dialog. And then I'm going to type a name for the new variable I'm creating, which is going to be called wheels, because it's an indicator variable for transport where I'm planning to represent wheels using 1 and legs using 0. And then I have to press the change button in order to put wheels into the output variable slot in that center box. Then I have to click on the old and new values button and type the string for the old value, wheels, and the number for the new value, 1, in the corresponding boxes shown by the arrows. And then press the blue button Add in order to put the instruction to change wheels to 1 in the old to new box in this dialog. That's symbolically represented with quote wheels end quote, and then an arrow, and then 1. That shows that I've successfully given SPSS the instruction to change values of wheels to 1, but now I need to add an additional instruction to change values of legs to 0. So I'm going to write legs in this box and 0 in this box, and then press Add again. Now both instructions are properly represented, so I will hit Continue, and then I'll be back to this dialog box, and I will hit OK. And you can see that wheels has been successfully added to the dataset. I'm going to repeat that step to transform material into an indicator variable. SPSS remembers what you did previously using any given dialog box. So when I've returned to the recode into different variables dialog, I'm going to have to remove the instructions from the transport variable. So I'll just click on that instruction representation in the center box and press the leftward pointing arrow in order to remove it from the box. And then I'm going to add material into the box, type the name plastic, hit the change button again in order to give a new instruction into this box. And then press the old and new values button again. The old instructions are still here, so I'm going to click on each of them and click remove. And then I can type my new instructions. I want to change plastic to 1. And then I'm going to press add to put it in the box of instructions. And I do the same thing with changing metal to 0. Once both instructions are properly represented here, you can click continue. And now plastic has been successfully added to the dataset. Plastic is an indicator variable with 0 for metal and 1 for plastic. I'm going to repeat those steps for color, but this time I have to create 3 indicator variables. So after removing the instructions for material from this center box, I'm adding color and specifying the first indicator variable of blue, hitting change to put blue into the center box, and then hitting old and new values. And I'm going to specify that blue is to become 1, and then I'm going to use this all other values radio button that's at the bottom of the set of options. And I'm going to specify the value of 0 over here. When I add that to the set of instructions, it's represented as else, and then an arrow, and then 0, meaning that everything that's not blue will be changed to 0 for this indicator variable. Then I'll hit continue on this dialog, and then I'll hit the OK button on the dialog that spawned it, and now I have blue successfully added to my data set. I'm going to repeat those steps for green, change color to green, specify that green is to become 1 and else is to become 0, and repeat the steps for red as well. Red is to become 1 and else is to become 0. Now I have 3 indicator variables for color successfully added to my data set. And finally, I'm done with data preparation, and I can start my simple linear regression model. So to fit a regression model the conventional way in SPSS, you can go to Analyze Regression Linear. There are other ways to fit regression models in SPSS that avoid some of the difficulties of data preparation that I just showed you. And if you want to know about those shortcuts, talk to me later. But this is the conventional way, and the way that might be easiest for beginners to understand. After going to Analyze Regression Linear, I get this dialog box, which sort of resembles the dialog from Jamovi, actually. In order to specify that price is the response variable or dependent variable in this model, I'm going to choose price from the list of variables on the left and press the rightward pointing arrow to plug it into the box for dependent. And then I'm going to choose battery from the list of variables and hit the arrow to put it in the independent box. That's the independent variables or predictors. And then I might be tempted to hit the OK button, and if I do, I will get the results of a regression model, but it will not have confidence intervals. So instead of hitting OK right now, I'm going to hit the statistics button in the upper right of this dialog, and I'm going to check the box for confidence intervals, and then hit continue. And then I'll hit OK. And now we get our regression output. SPSS gives some extra information at the top of the model output, so you have to scroll down to get the table of coefficients. But once I scroll down, I see the table of coefficients, and it has the same intercept, 63.64, and slope 1.81 that I got when I ran this model in R, and the t-test of the intercept and the slope, and both of them have p-values that are represented here by 0.000 after rounding, and I have a 95% confidence interval for the intercept and slope on the right-hand side of the table. Moving on to the binary predictor, I'm going to go to Analyze Regression Linear again. And as you know, SPSS remembers what you did previously in any dialog box. So the price and battery model is still here. I can click on the battery independent variable and press the leftward pointing arrow to remove it from the independence box, and then choose plastic, the indicator variable for material, and hit the rightward pointing arrow to put it in the independence box, that is the box for the predictor variables. I don't need to go to statistics and check the box for confidence intervals this time because SPSS remembered that option from the last time I was in this dialog box. And then I'll hit OK, and I'll get my output. So here's the table of coefficients from this regression model, and it's just the same as we got before, showing that plastic robots are $9.98 less expensive than the metal robots. Moving on to the multi-categorical predictor, again, I'm going to go to Analyze Regression Linear. And I removed the plastic indicator variable from the independence box and instead added these 3 indicator variables to that same box, blue, green, and red, and then press OK. And I get a summary table that has slopes for blue, green, and red, which represent comparisons between each of those colors and the reference point of black, just like in the previous 2 software packages. Here's the version with 2 predictors. I added battery and blue, green, and red to the independence box. That's the box for the predictor variables. And then when I hit OK, I get this output, which is a regression table that shows that the slope for battery is 1.85, adjusting for color, and the comparisons between each of these colors in black are shown adjusting for battery. Now I'm going to show you how to do the model comparison step in SPSS. This step sort of resembles what we did in Jamovi. So in order to set up a model comparison between a model that has battery predicting price and a model that has battery and color predicting price, I need to first set up the simpler model in the linear regression dialog box. So here I've set that dialog box up with price as the dependent or response variable and battery as the sole independent or predictor variable. But then instead of hitting OK to get the model output, I'm going to hit the next button right there. That allows me to have a separate independent variable box to add predictors to. So having clicked that button, then I get an empty box, and I can add the 3 indicator variables for color to that box. If I was to hit previous here, I would see that battery is included in that previous independent variables box. Here, I have the 3 indicator variables for color included in this independent variables box. I will get 2 regression models, one that has battery alone predicting price, and the other that has battery and these additional predictors predicting price, just like in Jamovi. But I'm not done yet. I have to press the statistics button again and add an additional statistic to what I'm requesting in the output. SPSS calls this statistic R-squared change, which I think is a confusing name, but it represents the f-test comparing the variance explained by these 2 models. Check that box, press continue, and then press OK. And you will see in the output that we have something called model summary, and this includes the f-test of the comparison between those 2 models. F is 10.23, just like it was in the other software packages. It has 3 and 495 degrees of freedom, and the p-value is very low, indicating that the model that has blue, red, and green added in explains significantly more variance than the model that just has battery. And then if we scroll down, we get summary statistics for both models. So there's a column added to the regression table called model, and in the section of it labeled model 1, we have an intercept and battery. And in the section of it labeled model 2, we have an intercept and slopes for battery, blue, green, and red, and showing that these are the two models that we're comparing by this f-test that we got up here. It is fairly common for students to misinterpret this f-test shown in this part of the screen as the comparison between the two models. It is not. This is the test that compares the more complex model to a model that predicts price based only on the mean price for every single observation in the dataset. It's not the comparison between the model that has battery as a predictor and the model that has battery and color as predictors. In order to get that comparison, we had to check that extra box for R-squared change, and we had to look at this part of the output up here.